Hello friends, I am Ronak and I want to share my experience with XLR. So I was enrolled in XLR for a software testing course, and I have to say right from the start of the course we were provided with the best service. I feel the quality of teaching in the course is the best, with live lectures every day, separate doubt sessions and also recorded sessions if you have missed the sessions or you just want to revise. Throughout the course, we learned manual testing, Java, SQL, Selenium, and TestNG framework. After the learning part was completed, interview preparation sessions were also conducted. So, proper guidance was given by the faculty, assignments were given to be completed, and group projects were taken, as well as we had to make individual projects, which proved to be very beneficial for us in sharpening our skills as well. So mock interviews were also held to make sure we get good placements. Finally, I got placed in many companies. So as my personal experience, it's the best institute to join if your dream is to get a job in IT and make a good career in IT. So just go for it.
Hi, I'm Sai Akhil and I'm working as a process consultant and data analyst in Siemens Technologies Private Limited. After joining XLR on my first day to the classroom, so I went there, I was really nervous because I'm entirely new to data science and data science is like an ocean. So I felt like how would it be, how would the faculty teach me and everything. The faculty was really good. They went on about teaching things in a really specific manner. What problems would you face as a data scientist and how would you solve it? So they explained everything in that manner. The business knowledge which XLR imparts on a student, so that's something which is really valuable. One more great thing about XLR is that there are really good value added courses which are provided to me for free without any extra fee, like Tableau, cloud engineering and big data engineering and some really good courses which are in demand in the market, which were to be learned along with the data science to be a good data scientist. So they gave me a Jumbo pass where they will give you all the training videos, provide you with all the training videos and some new videos which were about to come as well. So those videos I used to refer whenever I get stuck in work. It is like the bond that never ends for us and XLR. So that's a really great thing. I would definitely, without a doubt, I would say that XLR would be the best institute.
Hello all, myself Amit Kulkarni, currently working as associate consultant in Bristlecone, a Mahindra group of companies. A good thing which I see in XLR solution is that the feedback loop which runs here. So the model in XLR is such where student is not getting a one-way traffic where he is just learning and going to home. Here after the student is getting enough data to learn, he is given assignments bi-weekly or sometimes weekly. These assignments are coming up with some deadlines, like the deadlines you meet up in a industry where you work in. Those assignments come with a few set of questions and sometimes with a problem statement also. After getting a check from assignment team and mock interview results, the placement team moves our resume to the respective companies via HR. I got a call from Bristlecone company where the interview was scheduled, and the good things which I can share is that the questions which were asked were quite similar to that of what mock interview was scheduled. So after clearing 2 rounds with Bristlecone, I got selected, and currently I am working there as associate data engineer specifically, and my day-to-day work depends from varying types of tasks, from data quality to data science levels.
Hello everyone, my name is Ashish Gupta and I am a BBA graduate. So after graduation I was thinking what to do, like how to upgrade my skills and unlock my potential. Then I got to know about XLR and here I had enrolled for data analytics and data science course. So after joining the course, the teachers here are very helpful and experienced. They helped me a lot in clearing my doubts and all the topics. So after completing the course, then the assignments, the mock interview, the placement team guided me in finding the best possible job. Here the real life projects and resume building sessions are really helpful. They helped me a lot in my interviews. Eventually from XLR I got placed at Triveni Enterprises where I work as a marketing strategy analyst. So hence I would highly suggest XLR to students who are looking for a future in data science and data analytics, and a big thumbs up for XLR.
Hey, I'm Rashmi Sarur. I joined for the Jan 2023 Selenium course wherein we were given knowledge of software testing from scratch. The course covered both manual and automation training and also included live projects that helped me enhance my knowledge. Apart from training, the institute also provides pre-placement sessions and mock interviews that help me understand my weak points. They also provide placement opportunities across the country, through which I got placed at P-Test, Bangalore as test associate. I really thank the team for their efforts and their constant support. I highly recommend XLR for those who are looking for a professional course to kickstart their career. Thank you.
Hi, I am Shilpa. I am from Bangalore. I hold bachelor's degree in engineering. I had been working in non-IT field since 2013 to 2019, and later I did my course in software testing in XLR. During the training, I had a very good learning experience. The trainers were very good. We had a separate assignment sessions and we had a project sessions also. I got an opportunity to work on real-time projects, which is helping me in my career today also. I suggest everyone to go with XLR, as I am proud to say that I got an opportunity to work with, and even after having a gap of 3 years and switching my domain from non-IT to IT, I got lot of opportunities in terms of job. So thanks to XLR.
Hello, this is Sriram R. Shankar, and I've been the part of XLR for an year or so. I've previously completed my Python internship, which was core Python internship, and it was actually working on core Python, which also had project deployment in Python, which included data structures and very deep knowledge of Python. Since 6 months this year, I have been the part of full stack web development course at XLR. Interestingly, after 2.5 months or so since I started my course, I also got placed into a company called Central Technologies here in Bangalore, and I've been there for like 2 months for now. The full stack web development course had a lot of parts which were taught to the students, which included mainly front-end technologies, back-end technologies, and deployment using the databases. So the front-end technologies included popular technologies such as HTML, CSS, JavaScript, and the back-end included Java and Spring Boot. So the front-end technologies or back-end technologies both were taught right from the scratch. So even a student or a candidate who was from his or her non-technical background could easily was able to learn the technical stuff that was provided from XLR. Apart from this, there were online materials that were to be accessed anytime the student wanted, and we also were given live projects, assignments repeatedly. The tests were conducted from the institute, which gave me a lot of confidence in facing the interviews. Also, when I was selected from XLR, I was placed at a company called Central Technologies. I was actually posted to an ML intern post. Even later, even after getting placed, I was constantly in touch with the team. They asked me about how the work experience was, how I was feeling personally working at Sandrol. So we always had that touch with the XLR team. So I'm really grateful for the opportunity that was provided by XLR and the placement. They have been my constant support that I always wanted. Thank you, XLR.
Hello everyone, this is Vidhi Vinoj Kurup, and currently I'm working as a data analyst in Gartner INC. And I would like to be very thankful to the XLR Solutions that they provided me such a good direction throughout my journey, throughout the course. And talking about my background, like I was completely from the academician's field. I was a research scholar and I used to deliver lectures in the senior colleges. So you can understand, like I made a career switch from academics to the corporate, and it was challenging, I can say, but you should overcome it, and that's all all about our life. So I can say, like, if talking about the course in XLR, it is bit it is not bit a lot of interactive sessions you can see every day. Whatever, if you are coming out of the doubts, the mentors are always ready, the team is always ready to answer your questions or answer your doubts. So that's a very good part of the XLR Solutions, that they are ready for for answering your doubts. Talking about the course it went around 3 to 4 months of duration, and after that we were given up with the assignments. Those assignments were really helpful because it it covered almost all the topics involved in all the sessions, like including Excel, MySQL, Power BI, Tableau. So this assignment helped us to skill up more about this all data analysis. After that, we were given up into the live projects where, like, we were asked, like me myself, I have done the 2 projects with XLR Solutions, and those projects were really helpful in my career because it gave the real time scenario, like how the work goes on in the real time business world. So I would really like to thanks once again to the XLR Solutions for providing such a good guidance for me. And I would like to give a message to everyone, like nothing is impossible in this world. If I can do it, I can switch my career from academic field to the data analyst field. Why can't you all? It's everything matters, like your perseverance, your patience, your hard work, and everything pays off. I can say everything pays off, and XLR were the best mentor for me when I'm talking about my career. And I'd like to thank you all and all the very best for your career. Thank you.
Hi everyone, I am M. Venkata Yashwant Krishna. At present, I am working in 98th percentile company as a trainee developer, and I have got this job through the drive which is conducted in XLR. So I strongly feel that XLR is the best platform to secure any job in software industry, because I have done Selenium testing course under XLR, and it helped me to improve my technical skills in testing and also in developing. Weekly they will conduct like communication skills like group discussion, etc. So through that I improved my both technical skills and communication skills, so it helped me a lot in securing job. So I prefer anyone who wants to get a job in software industry, so you may join in XLR.
Hello, my name is Vishmita Matham. I am a BTech graduate student from Siddhartha Institute of Engineering and Technology in Hyderabad. I have taken my Java full stack development course through XLR. So, talking about XLR, it is a really great platform to all the students out there, to the students who are trying to build their skills, to the students who are trying to build their career in software field. It is a really great option. Now, talking about my personal experience, I really enjoyed taking this course in XLR. Coming to the faculty members, they are really experienced and very well taught to all the students. And talking about my personal experience, as I said before, I am placed through XLR and I'm really happy that I have got a job through XLR. And getting a high package job was really a tough time right now because of the recession, but because of this platform I am really happy for myself. And yeah, I really enjoyed it. That was my personal experience. Thank you, XLR.
Good afternoon, all. Hope all are doing good. So, yeah, we'll start the session. Today we have our trainer Shashank. So, yeah, Shashank, you can take up the class.
Sure. Thank you, Chandra.
Thank you.
My voice is clear, right? It's good.
Yes, it's good.
Okay, great. Fine. So we'll start. Okay. So first, today in this session, we'll start with the practical part. And first of all, we'll choose the healthcare domain. Okay. So first we'll go with the healthcare, and then next we'll go with the finance field, or you can say banking field. So there we will use we will try to predict the credit card fraud prediction. So first we'll start with the heart, or I can say the medical thing, and we'll do the heart, prediction. So let me share my screen first. Fine. You can see. Okay. So we'll start with the data set first, understanding the data set. I hope you can see my screen. So let us first start with understanding the data set, and then subsequently we'll try to analyze how we can do this using Python. So fine. So we'll take a few minutes to understand the data set. Okay. So here is a data set. Okay. So this data set is actually an ECG data set. So in this data set, we have multiple columns here. So you can see that the column names starts from column A to column U. So now in this data set, there are multiple parameters which are actually involved. And when you actually are using a certain thing, for example, like applying a machine learning or a deep learning algorithm, here we'll apply a deep learning algorithm. So in the last sessions, we have seen that what is a deep learning and what is AI. All these stuff we have actually understood and we have seen all these things. Now coming to implementation part, we will use deep learning technique because mostly AI is about deep learning technology. So now, while first of all, we should understand the data set while applying the data set into the application field. Now, since there are certain parameters, first we have to identify independent variables and dependent variables, right? So here, there will be many independent variables and there will be only a dependent variable, right? So, or you can also say that it is a target variable, okay? So here you have, when we get a data set, right?
So when we get a data set, we do not have, mentioned that, these are independent variables, or, this is a dependent variable, or these are all independent. So it will not be mentioned like that. So it is up to us to understand that, okay. So that is why understanding a data set is very important. Okay. So now, first of all, while understanding the data set, we will understand that business problem, what we are actually trying to do with this or using this data set. Okay. So now using, there is a data set in such a way with age, sex, smoke, years, ideal. So each column I will explain, and how or what are the on which scale they are being measured, and how we are going to use it. Okay. So now here, coming to the certain parameters, you can see the something which is called as a target variable. Okay. So here this data set is an ECG data set. Particularly, this ECG data set is actually used for heart rate, or you can say heart disease prediction, whether that person can get a heart attack or not. What are the chances that, if a particular person is having certain parameters like this, right? So if he is having certain parameters like this, right? These kinds of values with his, for example, like, height, weight, right? His age, right? His BP, right? His ECG, his Q wave. So if, the data is in a certain way, what are the chances that that person might get a heart attack, right? So that we are going to build a particular model. Okay. So we are going to build a model in such a way that we will predict that whether that particular person will get heart attack or not. So that is what we are going to do using the data set. Now, in this data set, since I told there are many parameters which are involved, right? Now, in this data set, the last column, you can see that it is a target variable. So that means where there is a zero, right? You can see here, zero. We'll go step by step. We'll understand the data set first, and then we can implement the, coding part. So here you can see that there is target zero, right? So it has been classified. Okay. So we have seen, no, there are in supervised learning, there are two kinds of learning. One is, I'm just writing here, see. So one is the classification and one is a regression problem. So basically regression is nothing but predicting the continuous variable, right? And classification is something where we are classifying either a binary classification or a multinomial classification. So either it is a true or a false or a 1 or a 0 and so on, whether that person is having a heart attack or not. So you can also consider this as yes or a no. So for example, here you have something called as 0, right? So here 0 indicates yes. Okay. That means the person is, sorry, 0 is no. And the person is not having a heart attack. Okay. So you can see that that person is not having a heart attack. Okay. With 1, we can understand that it is a yes, and person is having a heart attack. Okay. So in this way, you can also take it as 1 and a 0, or you can also take it as yes or a no. But it is very important for us to convert into 1 and 0 because of the model building. So that I will explain. Okay. So that is the reason we convert it. Okay. So either we can convert while we are data cleaning, right? Or we can also, if you don't convert also, in the direct Python code also, we can also convert. You can give that for S, you give 1, for 1, you give S, or S, you give 1. So anything vice versa. So for example, if you are having a simple yes or no, we can say that for S, give 1, and for no, you can give 0. So in this way, you can, also assign a particular value also. So in this way, we can do it. So now here there are certain parameters like sex, smoke, ideal, and all. We have just, I've just described that, right? So here at the last, we have the target variable. That means if this particular person is having this certain attributes, right? If this person is having this kinds of attributes, for example, he's having age 65 and so on, like this, if he's having a certain attribute, okay, if he's having a certain attribute, what are the chances that he will be having a heart attack? So that we can predict on the unseen data. So now here in this case, if this person is having certain characteristics like this, his age is 65, 0 indicates that he's a female, right? Oh, sorry, she's a female, he doesn't smoke, right? And so on, and his lifestyle and all those aspects, and that particular person is not having a heart attack, right? Because it is given 0 in the target, right? So this is the outcome variable. So target variable is also called as a outcome variable. So here that particular outcome is that person doesn't have a heart attack, even though he or she has some characteristics, that particular person is not having a heart attack. So this is what the understanding actually of the data set. Now coming to the other parameters of what these are. Okay, there are certain some more parameters which are actually involved. So now here coming to the target variable. So since this target variable is depending upon the certain factors, this target variable becomes a dependent variable. This target variable becomes a dependent variable, and the other variables which are like weight, height, HR, DM, systolic, diastolic BP, all those things are basically the independent variables. So that particular variables become the independent variables, and the target variable becomes the dependent variable. So because we have to divide the data into independent and dependent variable. So our independent variables, see, this is actually a classification problem, because we are classifying a simple yes or a no, or a 1 or a 0. So simple classification for a yes or a no, or a 1 or a 0. So this is what we are actually trying to do. Okay. Now, since there is simple yes or a no, or a 1 or a 0, a certain scenario which we are classifying, right? So classification matters, when we apply classification methods or a classification technique, when that particular outcome is a classifier, right? Or a classification method. Now, the input variables can be a regression, variables as well. So for example, like a height, right? So height is basically a continuous variable, right? So here the independent variables or the input variables can be a continuous variables, but outcome can be a classifier, or outcome can be a categorical variable. So we can also say it as a categorical variable. So the outcome is a categorical variable, or you can say the target variable. Now going into the each and every I can say attribute. Now let us try and understand that how these attributes are and how these attributes actually contribute, right? So now here you can see that certain elements like, for example, age, right? Sex, height, and weight, or you can say sex as gender. So age, gender, height, and weight. So these 4 are called as the demographic data. Okay. So these 4 are demographic data. So first we'll have some understanding of what are the parameters, and then we can go forward using the data set, that how we can proceed further and understand and build a model for the target variable. Now we have age, gender, height, and weight. So these are called as the demographic data. And then we have the things like smoking, years, and smoking when he's active with his things, and then the lifestyle. So these particularly come under his lifestyle techniques, his behavior, or you can say lifestyle factors. Yeah, that should be a correct word. And now the other metrics such as the other metrics such as the LDL. LDL is basically for cholesterol. Okay, so I'll explain each one again. So like LDL, BPSYS, right? BPSYS is nothing but the systolic BP. then the diastolic BP, then the HR, which is nothing but the heart rate, and then DM is the diabetes, then HTN is the hypertension, then IVSD is nothing but the interventricular, septum thickness, whether it is present or not, and then ECG pat, which is the ECG pattern, and then Q wave, which is the Q wave presence, right? And then there are certain things called as FH. So FH is nothing but the family history of heart attack. And then ischemic heart disease is for IHT. And then CHP is for chest pain, right? So there are like this many factors, right? So what does it mean for a person to understand that by seeing this data, right? So that is extremely important. When we look at a certain kind of data, what we understand by this, right? So what we understand basically is about that there are certain parameters which are there, right? Which are contributing to the outcome, or which are contributing that a certain person will get a heart attack or not. So there is a certain amount of data. That means there are certain factors which are actually contributing for a particular outcome. This is what our understanding actually should be. So that means there are certain factors which are actually contributing. So based on these certain factors, you can tell whether the person will get heart attack or not, right? So this is how things are going to work. So this is how the data is. Now coming to the demographics and lifestyle. Sorry. So coming to the demographics and lifestyle, and the first one is the age. So our data set, in our data set, our age actually values, or you can say the people who are in the data set, their age varies from 20 to 90. So it varies from 20 to 90. Then the gender, which sex or gender we can say. And here, if you can see, usually this age, no need to explain much. No, this person is 53 years, this person is 50, 39, 40, 65, and so on. So it's just age. So nothing much to talk about. That is particular age. So it is usually varying from 20 to 90 in our data set. And now coming to the gender or sex, there are two genders which we have considered. So there is no third gender in our data set. So there is only two genders. One is female and male. So for example, if you see 0, it is a female. And if you see 1, it is a male. So usually by the industry standard, we take for female as 0 and 1 for male. So here you can see that this first person is a female. Then it's a male, then female, female, male, 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 and so on. So you can see that the people are male and female. So different two kinds of genders what we have. So this is the next thing. So after that, we have the smoking. And for smoking, it is two things. One is the non-smoker and smoker. So for example, here we can understand that for smoker, it is 0. And for non-smoker, it is 1. Okay. Sorry, for smoker, it is 1. And for non-smoker, it is 0. Okay. So for example, if you see that the person is having 0, right? Here you can see that it is 0. That means he's a non-smoker. Okay. So I will share the documentation with you that based on this, how the data can be understood, and then the coding part as well as the model building and all. We will share it to you. So here 0 indicates that is a non-smoker, and 1 for example, this person who is 61 age, right? So who is a 61 age, and 0 indicates she is a female, right? So a person who named or whose age is 61, and that particular person is a female, and she is a smoker because it is 1. So 1 indicates that that particular person is a smoker. Okay. And next column indicates that number of years. From number of years, that particular person is smoking. So here you can see that the person is smoking from 45 years. Okay, so she's a she's an experienced smoker. So in that way we can understand. For example, if we go down, you can see the person with 19 years, right? So this particular person is aged 39 years, and this person is a female because it is 0. And here you can see that she smokes because it is 1 in the smoking part, and then she is smoking from 19 years. Okay, so this is what the understanding should be. Okay, now, so after the years of what we have done, so next thing is the LDL part. So LDL is nothing but the cholesterol level. Okay, so the cholesterol level actually ranges from 26 to 260. Okay, so this is the ideal, or I can say usually what human beings actually have. Okay, so it varies from 26 to 260 in our data set. Okay, so here it is about 69, 117, 86. Okay, so something above, maybe you can think like, something above 130, 140, they're having more cholesterol. So here you can see the person is having 260, right? And you can see here this particular person who is a male, actually 53 age, and he doesn't smoke actually, right? So since he doesn't smoke, his number of years of smoking also will be 0. Correct? No, if he doesn't even smoke, how can the number of years be at least 1 or something? It won't be, no. So wherever you can see in the smoking status, if you see 0, obviously the years of smoking also will be 0. Okay. Okay. Fine. So where we are, this 260%, no? Yeah. So 53 years of age, and this fellow is a guy, is a boy or a man, I can say, and he doesn't smoke, and 0 years of smoking as well, and his cholesterol is 260. Maybe he eats, so much. So in that way, this LDL will help you. So LDL is nothing but the cholesterol range from 26 to 260. So next is the next comes the CHP. Okay, so next comes the CHP. So CHP is nothing but the cholesterol phenotype. Okay, so this one is not actually given like the cholesterol level from our cholesterol, which is LDL. Sorry, that is ranging from so that is ranging from 26 to 260. Correct, no? But this one, this CHP actually ranges from it is actually measured on a scale. Okay, so there are 4 scales for that, for measuring the CHP. So cholesterol phenotype, and the scale is between 1 to 4. Okay, so maybe you can think like this: 1 means low, yeah. So 2 is he's having a little bit amount. 3 might be average, and 4 might be high. So you can think like that. So it is on a scale of from 1 to 4. Okay, so 1, 2, 3, 4, 4 levels of CHP. So here that's what levels are given. So this fellow is in the 4th level. Okay, cholesterol phenotype, and this person is in 2nd level. Okay, and this person is in the 3rd level. This person is in the 1st level. So you will not have 0 actually. You can check. You will not have any 0 because the scale is from 1 to 4. So since the scale is from 1 to 4, it starts with minimum cholesterol phenotype will be 1, and it will go to a maximum of 4. And then obviously the height and weight, no need to explain height and weight in the data set. So obviously height is nothing but the height of a person in centimeters, right? This first person is 168 centimeters. She is a female, no? Yeah, sex is 0. So she's a female. So she is 168 centimeters. Then he's a male, 145 centimeters, and so on. So this is the height and weight, right? So obviously weight will be in kgs. Correct, no? So this person is 111. Okay. So usually you can see that very rarely people with very, very less weight will have heart stroke. So very less it will be that the chances. So I'm not saying no, because obviously there is something called as a good cholesterol and a bad cholesterol. To measure that only, we are using that LDL and CHP. which measures the both good cholesterol and the bad cholesterol. So to understand that, what is the average weight to to identify that uh, you know that a person will be having heart attack, or is not having a heart attack. So weight also is very important when it comes to this aspect in the data set. So height, it's in centimeters, and weight is in kgs. So till there we have done. Now next, going to the FH. So FH is nothing but the family history. That means FH is a straightforward thing, whether that maybe you can say your parents, your grandparents, your family history, where whether your family history there is a heart attack in your family or not. Okay, so we cannot say that the 100%. We cannot say that this family history will be so much of that will be a factor, but we can have some idea whether there is a history of there's a history there's a history of the heart attack is there in the family or not. So it is better to understand whether there's a history or not. For example, here I have taken that if there is a family history, it is a yes as one, and if there is no family history, uh, uh, you know, it is zero. So this first person, who is a female, she's having a family history because it is one. That means in her family there is a history of heart attack. So there is a history of heart attack, and now this person is zero. That means there is no history of heart attack. So this is how you can understand the data set. Okay, right. So before we go even further, any more anything you want to ask? At that couple of minutes, we can have some doubts, because yeah, there is much more to explain the data set. Then we can go. So why I'm stressing much on data set as well, because it is very important, for us to understand the data set, very one in a good way, because each, I can say, each variable, right, or I can say each independent variable, or variables in the data set, each have their own behavior, right? So each have their own behavior, their way of contributing to the target variable. So understanding them and how they affect is very important. So particularly for data sets like this medical data sets, right? So there may be some 10 factors, there may be some 12 factors, there will be some 5 factors which can contribute. So in this case, we should identify that which factors are contributing more towards the towards that heart rate prediction, right? That the person will have heart attack or not. Now here, so yeah, till family history we have done. So I was just asking this, any, whether you are having any doubts. Just waiting. So I'm checking the chat. Nobody has any. So anything you have, you can please ask me. Okay. I think no one's having any doubt, I guess. Okay. Okay, fine. So I'll move ahead since there are no doubts from anybody. Okay. So till family history, we have seen whether that particular family has, a history of heart attack or not. Okay. So next is the active status. So active is nothing but the, physical activity. For example, you may go for running, you may go for jogging, you may do gym, right? You may do yoga, right? You may do different kinds of, any physical activity where it is going to help you to reduce the body weight, or not just the body weight, also to keep you fit, correct now? So also to keep you fit and you keep you healthy. So why this particular uh, you know column also has been taken, because we should definitely understand whether he is doing some physical activity or not. So here, unfortunately, our people are not having much of physical activity, as I can see from the top, because here I'm taking 0 for inactivity and 1 for he's active. So here you can see in the top 9 observations, there is only one person who has, or you can say he's active, or he has some physical activity. Okay. So this is also can be a factor which can contribute, you know, towards the heart diseases. So next comes the lifestyle. So lifestyle here, basically lifestyle is nothing but it is depending upon your habits. For example, the kind of food you eat, the things you do, right? So this actually varies from 1 to 4. So that's one varies from. So I think it's 1 to 3. Yes, 1 to 3. Yes. So lifestyle is actually thing. Yeah. So lifestyle is basically where they live. So that is very important, because how based upon that you can decide whether what kind of quality food. Usually, the people who are living in cities are, are generally described that they don't eat much of quality food. So that's what lifestyle is basically about. And here you can see that in the lifestyle, one indicates that that particular person is from city. Okay. So one, yeah, yes. So one is for that person is from city, and 2 indicates he's from a town, and 3 indicates that he's from village. Okay. See this way. Okay. So that particular person is from village. So for example, wherever you see 3, that particular person is from village. Okay. So 1 is city, 2 is town, and 3 is village. Okay. So data has been collected from multiple places. So that's why it includes all the 3 elements, which is city, town, and village. So next is the IHG. Just a minute. Yeah, IHT, right? Yeah. So IHT is basically whether that particular person is having the ischemic heart attack or not. So I can say heart disease. Okay. So this is a kind of this ischemic heart disease is nothing but a way of whether that particular person is having an heart related problem or not. So if that particular person is having that heart related problem, we are classifying it as 1. And if that particular person is not having that particular problem, we are classifying as 0. That means if it is a 0, that person is not having, and if it is 1, that particular person is having. Okay. So next is the heart rate. Should be heart rate. Yeah. So, uh, yeah. So this heart rate is basically measured in BPM, which is heart rate, sorry, beats per minute. And there's actually there's a certain thing that the lower your heart beats, the more you live. Your heart should not beat very fast for longer amount of time, because if you're having, for example, I think 72 to 75, maybe even 80, we can consider for a human being. So yeah, maybe 70 to 75, it is normal, because that's what God has given us. So if it beats, for example, your heart beats, consistently 90 BPM, that is beats per minute. So there is a high risk that, you may die very quickly, because that is where HR, heart rate is very important. And if the heart, beats very slow, I'll tell you one small example of, I don't exactly remember this, how much it is, around some 20, 25, I guess, not sure, I think 20. For tortoise, it is basically around some 20. That's why the tortoise lives for longer years, because its heartbeat is very less compared to, for example, like a human being. So, slower the heartbeats, the longer you will live, and more. Let us check in the data set. So usually it's around 70 to 75, I guess. Okay. So here you can see people are having around some 98, 85, 63. Less is good actually. Less is good actually. So 74 also fine. 89 is more again. Correct now? Then 85 is more again. 118. This is too much. Okay. So I think this person will definitely have heart attack. See. You can see this line. This 118, you can see that particular person is having the heart disease. Obviously, you will have, because 118 times is, ridiculously very fast and very dangerous also. So yeah, 69 is less, so definitely he'll not have, I guess. Yeah. So 96 is also more actually, to be fair, but not as more as 118, but it is still, 96 is also more. 73 is also fine. 77 is also fine. 116 again more. Right. So like this, you can take the heart rates per minute. So next is the DM. So basically DM is the diabetes level, whether that particular person is having diabetes or not. So here, if the person is having diabetes, it is given as 1, which is a yes. And if the person is not having diabetes, it is given as 0. Okay. So next is the BP, systolic BP, and diastolic, diastolic, yes. So systolic and diastolic, yes. So systolic and diastolic BP. So basically, systolic is nothing but SYS. It is BP systolic, or you can also rename it as systolic BP. So systolic BP is nothing but the upper number in the BP. For example, usually the BP should be between 120 by 80, correct? No? So for example, if it is 120 by 80, the 120 number is called as the systolic BP, and 80 number is called as the diastolic BP. So here you can see this person. So here you can see that this person is having a little bit high BP, 150 by 70. So the down part is less than the normal, and the upper part is more than the, and here 110 by 60, right? And so on. Okay. So it's not necessarily BP, if it is very high, you are getting a heart attack. Correct? No? That is not happening. Okay. So each one individual observation and all we will not see. As a whole data set, we will actually analyze and understand. Okay. So systolic is the upper number and diastolic is the lower number. So next comes the HTN. So HTN is nothing but the hypertension status. Okay. So hypertension, whether that particular person is having hypertension or not. So for hypertension, if the person is having hypertension, we are giving it as 1, and if the person is not having, we are giving it as 0. So you can see that the first person is having hypertension, and the second person is not having, again having, not having, not having, having, and so on. Okay. So after that, next is the IVST. Okay. So this IVST is nothing but the spectral defect. So there is again interventricular spectral defect. It is one of the contributing factors for checking whether that particular person will have heart disease or not. So IVST again, it is divided into two types, or two classifiers, or two categorical classification, which is yes or a no. For yes, it is 1, and for no, it is 0. So the person is having a defect here, all 0, 0, 0, 0. Correct? No? Here there is 1. So this person is having that defect. Okay. So this IVST is something where whether that person is having that interventricular spectral defect. Okay. So yes or a no. And next is the ECG report. I think this is also on a scale from 1 to 4. Yeah. So these are again patterns in the data where it ranges from 1 to 4. So on the scale of 1 to 4, so I think you can see here you can see the data set from 1 starts with 1. There is no 0, and it goes to a maximum of 4. Okay. So it goes from the measurement goes from 1 to 4. So next, yeah, final one, last but not least, the Q wave. So Q wave is nothing but the when you take the ECG, electrocardiogram is what ECG is about. So when you take this ECG report, you also get a graph. It's a sine graph actually. So it is a sine graph, and that graph is called as a Q wave. Okay, and this wave. The wave here it is measured in 2 again, which is yes or a no. So wherever you see 1, this is basically the Q wave is present, and for for the who doesn't have this abnormalities are basically the because the presence of Q wave is an abnormality only, actually, to be fair. So if the Q wave is not present, it is a no situation, so it is a 0. And if the Q wave is present, it's a yes situation, and it is given as 1. Yeah, so it is given as 1. So basically it is 1 and it is 0. Yeah. And now this is what the variables are about. And now our, the final friend, which is the dependent variable, which is the target variable or the dependent variable, right? Or the outcome variable. So we can call by many names, right? So we can call by many names, and who is where we are having the disease, or we are not having the disease. So that is what we have to predict. So this is the data set. So I hope I've explained the data set in clear. Okay. So I took some 40 minutes, but I felt understanding the data set is extremely important, because once you understand what are the factors which we have in the data set and how they are contributing, we will see by doing the analysis. But understanding the data set is extremely important, right? And now let me go into the Python part. So before that, anybody is having any doubts, you can ask me. Anybody Any doubts? Please let me know in the chat. I'll just answer your question. Anything you have, you can ask me. That's not a problem. Which is completely related to our discussion, what we are doing here. So let me share my Python screen. Let us go ahead and understand the implementation in Python. So for implementing in Python, I'm using the Jupyter notebook. You can also use the Jupyter lab. Okay. Or you can also use the Google Colab also. Okay. You can mostly, for data science, we usually prefer Jupyter notebook, Jupyter lab and Jupyter notebook. And then we can use the Google Colab also. And we can also use the Visual Studio, where there also you can code. So mostly, I usually use Jupyter Notebook and Jupyter Lab. Sometimes I also code in Google Colab also. So Google Colab is for the cloud-based, and Jupyter Notebook and Jupyter Lab, you can work offline as well. So fine, I'll just share my screen. I think my Python screen is visible, so it should be fine. Okay. Great. Right. So let us understand slowly in detail. So here you can see our business problem for this session and or this data set. What we are using is to predict the the heart disease, right? That the particular person will have heart attack or not. So if you're able to build a model and in such a way that it can predict correctly. So once you pass into the once you pass into the unseen data, or when you pass an unseen data, our model should be able to predict whether using these certain parameters, right? Whether the model, or I can say whether the person who is actually having this particular kind of symptoms will get a heart disease or not. So this is what we are exactly trying to do. So this is for the healthcare providers, where they can use this data set to build a model and develop a model where it can predict the heart disease. So this is what we are trying to do here. So what happens if the person is, I can say the person, our model is able to predict correctly that the person will have heart attack or not. So for example, if there is a risk of any heart attack, you can take a preventive measure, correct? No. So you can take a preventive measure so that the person, might not get heart attack and he might be saved from getting the heart attack. So it is extremely difficult for us, right? Because, the preventive measure is extremely important, correct? No. So that is a tough part, what we have to go through. But there are good results, if you do the process using the deep learning methods, right? If you're able to build a model and predict in such a way. So it will be useful for the, people and the doctors, right? So now let us understand, in detail, step by step, and how we can actually, know things, right, and move forward, that how to build a model. Okay. So for this entirely, we are going to use the deep learning methods only. We are not going to use any machine learning algorithms. We are going to use the deep learning models only. Okay. So now going into the data set, there will be libraries. Okay. So we'll go step by step. There are certain libraries which are called or which are installed. And let us understand each library, right? And each library and its importance. Okay. So why this particular library has to be, I can say why it has to be used, and what is the need for it, and what happens, what functions can be used, or what modules can be used, so that we can understand, right? So let us start with the, libraries, right? And one important thing is defaultly, some of the libraries will be installed when you use Jupyter Notebook or Jupyter Lab. And mostly it will work if already you have Google Colab using, because Google Colab is a cloud-based compiler platform. So what I'm showing you is the Jupyter Notebook, right? Here you can see the name Jupyter. Okay. So this is a Jupyter Notebook. So in this, we have to install certain libraries. For example, some will be automatically there, and some will not be there. For example, if you want to install any library, for example, like C1, okay. So it is very important that how do you install? So here you can go to insert and a cell above. So there is a small code which can be used, which is pip install cbon. Okay. So if you take pip install cbon, pip is a code to install the library. Okay. So a library or a module, you can use it to install by the syntax pip install. Okay. So if you use pip install cbon, pip install pandas, pip install numpy, okay, and so on. So you can run the code, and okay. So here it will, if I run, it will show that it is already installed. The requirement already satisfied. Okay, because already I've run the code, and all the libraries have been already installed. Okay, so whatever is not installed, you can install it. All right. So basically, there's a small explanation I wanted to give. Okay. So there's a small explanation. What I want to give is nothing but the, here you can see some of the things called cbon, right? So this is for pandas, this is for numpy, and this is for matplotlib. Okay. So now we have to understand that what are modules and what are functions and what is a library, right? So for example, first to understand this, first we have to understand the functions. So functions are nothing but an individual parameters which are used to process something. For example, you can say addition, multiplication, right? So in any statistical function like applying mean, median, mode. So these are all functions in the data set. So something which consists of a collection of all these functions is basically a module, right? And collection of all these modules, which is basically called as a library. So library is a bigger picture, right? In the library, library is basically a collection of all, I can say, it's a collection of all functions and modules. Okay. Now let us go bit by bit. Okay. So here you can see import cbon as SNS. Okay. So cbon is nothing but a library. Okay. So I'll just change with this, right? Usually we start with numpy. So I'll just change it. And then comes the pandas. Should be. Oh. Yeah, it's fine. Right. So now here this SYS is a system module. Okay, it's a module. Now next comes the NumPy. So NumPy is basically the full form of NumPy is numerical Python. Okay, so numerical Python, we use an alias name called as NP. Okay, so NP is an alias name for NumPy because whenever we want to use the NumPy library, we can call as NP. Okay, so now here NumPy is basically used for arrays. Okay, so this numerical Python has all the mathematical operations which are there, and it also can apply or you can say it can it can process the arrays faster. Okay, so to handle the multi-dimensional arrays, we can use the NumPy library. So next comes the pandas. So for pandas is mostly used to call the data frames or use the data frames. So data frame is nothing but something which can be put into some rows and columns like a table, right? So for example, we are importing a data set. So data set consists of rows and columns, no? So we can use the pandas because that is what the data frame is about. So for pandas, the alias name is PD. Okay, so PD is the alias name for pandas. So then comes the matplotlib.pyplot as PLT. So matplotlib is used for data visualization. Okay, so it is used for data visualization. So here matplotlib is the library, pyplot is the module, and PLT is the alias name. So this is what the segregation in matplotlib.pyplot. Okay, so here you can see one more syntax, which is percentage matplotlib inline. So what is this matplotlib inline is basically about is this is basically used to fit the graph inside the Jupyter environment. So it doesn't go outside the environment and it will be sufficient inside the environment. For this, we are going to use the percentage matplotlib inline. Okay, it's a very important because usually what happens is if there's a huge amount of data and we are trying to build a graph or data visualization. So usually what happens is the visualization sometimes goes out of proportion. For this not to happen, we use the percentage matplotlib inline function. So next is the Seaborn library. So here you can see Seaborn as SNS. So that means the alias name of Seaborn, we are using it as SNS. Okay, so you can give any alias name. So whatever alias name you actually give, that alias name you should use in the functions. Okay, and here you can see that you are giving Seaborn, right? So basically, Seaborn is a data visualization module, which is which is very similar to the matplotlib. But there's a difference between Seaborn and matplotlib. So basic visualizations are done in matplotlib and advanced visualizations are done in Seaborn. That means particularly you can think like mostly statistical. Yeah. So mostly statistical, visualizations. Yeah. So mostly statistical visualizations can be done inside Seaborn. So you actually Seaborn is actually built or it has been developed on top of matplotlib. So whenever you want to use Seaborn without matplotlib, you cannot use Seaborn. So it is like that. So these are some of the libraries. Next, we'll go to the machine learning library, which is the sklearn. Okay. So you may get a doubt. So since we are doing deep learning models, why machine learning techniques we are using? We have to use some of the techniques like the model selection, classification report, and the accuracy score. because these are some of the metrics which can be used for whether we are using machine learning or a deep learning model for building a classification report and doing the model selection. Okay, so now here the metrics sklearn. First of all, we'll see what is a sklearn. So sklearn is nothing but a scikit-learn. Okay, so scikit-learn basically has the machine learning tasks. So next here you can see from sklearn import the model selection. So model selection is for the selecting the model, right? And next is the metrics. So classification report and accuracy score are the metrics, because why we are using this metrics as classification report and accuracy score is, for example, because this is a classification problem. Okay. So I'll just put like this. Because it's a classification problem. Okay. We can put it here. Okay. Because it's a classification problem. Okay. Because our outcome is a categorical variable. So it is having ones and zeros, no? So it's a categorical variable. So since our variable is a categorical variable, so the outcome is a classifier or a categorical outcome with ones and zeros or a yes or a no. So it's a classification problem. So for classification problem, the metrics will be classification report, accuracy score, confusion matrix, right? All these things, AUC, ROC curve, all these things will come. For example, our outcome is a continuous variable, or we are using a regression for outcome. Then we will have the different kind of metrics, which is the mean square error and the root mean square error. So these are used for the regression. So this is one, that one, let us not, go into that. So let us talk about the metrics, which is for the classification problem. And here the next we'll go is Keras. So now all these things which are selected are related to deep learning. Okay. So understanding this also is very tricky part. And here let us go, the starting important one, because first we'll use the Keras. Okay. So Keras is a platform to implement the deep learning along with TensorFlow. So here next is the utilities, which is the to convert to a categorical. So for example, wherever you need to convert to categorical variable instead of a numerical variable, so we use the utils function. So next is the sequence function. So sequence function is basically to compile in a sequential order. Okay. So next comes the layers, keras.layers. So layers is the number of layers we can create. So we are giving the module as dense because we always create a dense layers, because it might be, hidden layers such as 3 layers, 4 layers, and so on. And the next thing is the optimizers, which is TensorFlow. We already have discussed with, what is this TensorFlow? I already told you that it is a Google's, deep learning mechanism implementation. So TensorFlow.keras.optimizers. And we also, last session, I think on Friday, we already have discussed that, what is ADAM, right? Adaptive momentum estimation, right? Momentum estimation. So ADAM is the optimizer. And next is the layers, which is the dropout. So dropout feature is used when we want to, maybe drop out, drop the, if the model is overfitting or underfitting, we can, stop the fitting of the model using a dropout. And then to solve this, this problem of overfitting and underfitting, we use the regularizers. So regularizers like the regularization techniques like the L1 technique and I'll just mention here L1 lasso regularizers, and then the L2, which is the ridge regularizer. So there is L1 and L2. Okay. So next comes the early stopping, which is the once we actually build a model, and we also discussed about the dropouts, right? So wherever we want to stop early, we want to drop the model building, and we know that the model is not performing well, but instead it is degrading. We use the early stopping methods and the dropout functions. So these are these are the libraries and modules and functions what we are going to use in our project of. So how do the very important question, I don't know whether you guys will ask me or not, but I'm only taking up that question and answering. There will be a question usually whenever I explain this to people. The question mostly I get is, sir, which kind of which modules or which functions or which libraries, how we will know that we have to import this particular function only. So that actually comes through experience. So when you understand that, okay, so we are building a model, that is why we plan the by the business objective, we plan the project, right? So we will understand that, okay, so okay, fine. So I want my optimizer to be Adam. Okay, so definitely my outcome is a categorical variable. So I need that utils function which can convert to categorical. And obviously, since it's a deep learning model, we want layers. So obviously, when we build layers, we want the dense function. So whenever that there are layers, definitely there is a dropout also, because not every time our model will build in a certain way that there is no need to create a dropout. So so in this way we will understand that which library to be used, which function to be used, which module to be used. So that one comes to practice and learning things. Okay. So now, before going into the next part, that reading of the file and all, let us take just a 5-minute break. Okay. So I was middle in discussing the I was discussing the metrics of which library to be imported and all. So I didn't wanted to stop. So let's take some quick break, and let us come back very fast. Okay. Okay, so let us continue. Sure, sir. I'll send the code. Um, Srinivas, sir, you message me. I will send the code, sir. That is not a problem. I'll send the code as well. So, anybody, anything you want to ask, you can ask me. I'll just wait for a couple of minutes. So, till what we have discussed, you have any doubt, you can ask me. So then we'll continue with the another part of the code, and we'll understand step by step process what what or how we can implement the implementation of deep learning. So we are using Keras and TensorFlow, sir. We are not going into sir, if we take this problem as prediction part in a real time can be used for prediction. Yes, it can be used, ma'am. But if you change the data, or you're applying on a different kind of data set, you have to build the same model. But sir, ma'am, one way to understand this is basically when we are implementing a certain part by using a certain data, because see, the model I will be building for this project is based upon the data what I have taken, or the data set what I have taken. So if the data actually adds to this data, or maybe you are taking some other data set for heart rate, uh, you know heart attack prediction, you can again build a model. But one thing to understand is the modules what we are using, for example, like the Keras, TensorFlow and all, that will be almost say, for example, if you are using optimizer, you have to use Adam. So that there you have to use the TensorFlow.keras.optimizer. So the coding part mostly remains the same. uh, Here and there little differences we have to make in the code. So basically the projects, some of the projects are there in the market, so we can make use of them, and we can change the code, and based on our purpose we can build a model as well. Sorry, but it needs to label like yes or no, like that, or else whether they are affected or not. Yes, ma'am. So giving labeling it according to our convenience is basically called as a data cleaning. For example, the data set what I showed you, right? So the data set what I showed you is basically cleaned data set. Why? Because why I'm telling is, there are no missing values, and none of that sort. So that I'll show that, so it's actually a cleaned data set. So I'm not going so to do 10 hours of time constraint, I'm not going into the data cleaning, data preparation part and all. But usually we need data cleaning. For example, like this uh, this data set has one more column. Actually, it has name column also, but due to privacy data privacy issues, the name has been removed in the data set. So because we don't need also the name also, so it doesn't matter, we are using the data, we want the numbers, right? And whether our outcome will be a categorical or it might be a numerical value, that depends. Your data shows a target variable. Ma'am, see here, ma'am, right? Yeah, okay. So here, so yeah, okay, your question is a valid one, and a way to answer this question is, our data set will have an outcome variable, ma'am. Here in my case, I have renamed it as target variable. Okay, so I have renamed it as target variable. But if you take, for example, like some other data set, it might be with some other name. That column might be with some other name. It is up to us to understand, or it is up to us to identify the target variable. So see, when you see a data set, the first analysis what we have to do it in our mind is to look at the variables and understand that what these variables are actually doing in this data set. So once we understand that what is happening in this data set, uh, you know then we will be able to understand that who is my predicted variable, or who is my target variable, or which is my dependent variable, and the rest all will become an independent variables. So I have just renamed it as target variable, but any data set which you have if you come across, we can identify in that particular data set. For example, it might be some 10 columns, it might be 20 columns, so it might be 15. So any number of columns data set, obviously it will have a target variable, or it will have a outcome variable. For example, if you take a HR attrition rate, if you take a HR data, HR attrition rate is nothing but whether the employee will stay in the organization or not. So the outcome variable in this, whether it is an yes or a no, right? It's a simple yes or a no. Why? Because whether the employee will stay or not, right? So in the same way, our data, since we are talking about medical data, I've taken a medical data set. So here we are predicting, the target variable is telling us whether that person has heart attack or not. So that data is actually recorded. For example, like the person, this particular age, he's a female, or she's a female, right? And she's having a BP like this, her heart rate is like this, and so on. Her lifestyle is like this. So and then in real world, when it has been tested, we found out that okay, yes, this particular person is having a heart attack, or this particular person is not having a heart attack. So this we need to understand. That is what the data is about. So we can easily identify the target variable. Just we have to when we see the data, just we have to analyze that what is there in the data set. So that is why it's very, very important for us to understand the data set. So even that is the reason also that I have taken some time. I think around some 40 to around 40 to 45 minutes I've taken to make you to understand that what is the variables inside a data set. And don't think that since I've renamed, you can see it as a target variable. But you will not have something as a target variable. It will be with some other name, whether that person is having heart attack or not. So it may be a yes or a no. So it is up to us to understand. Okay, sir, but we have to analyze and study about the data to identify dependent variables with corresponding values. Am I right, sir? We have to analyze, ma'am. Yes, we have to analyze the data set. So to study these variables, to identify a dependent variable, obviously, ma'am, yeah, you have to have some knowledge, some statistical knowledge, that how we can differentiate between independent variables and dependent variables. Yes, that is obviously correct. Yes. Yes. So, once you are okay, okay. So when you are actually going, you are doing these projects, or you build, even for research, it's the same. When we collect the data, we try to, identify the independent variable and dependent variable, not just for the real-time project, even for research field also, we do the same thing. So that's why, we study research methodology, which will actually help us to understand the statistical methods of how to identify the independent variable and the dependent variable, and how to how this independent variables are contributing, or which independent variables are contributing. Because what happens in real time is, for example, our data set might have some 20 variables, 21st variable, sorry, yeah, 20 columns or 20 variables, and 21st variable might be a outcome variable. So here, these 20 variables are there, which are independent variables, and that 21st is the outcome variable or the target variable. So now let us understand, when we do start doing the analysis part, maybe some 20 variables which are there, maybe some only 10 or maybe only some 8, right, are contributing to the outcome variable. So contributing is nothing but which are actually helping us to predict the outcome variable. Contributing is, very simple language, which are directly reflecting on the target variable. So if these 10 variables are only creating a direct proportion, which are helping us to predict the outcome variable. So we take these 10 variables. That is why we call it as a feature engineering. So in the feature engineering or feature selection, we try to identify which variables are contributing. That is where our statistical methods and our machine learning algorithms or deep learning algorithms will actually help us. So it will help us that which variables are contributing directly to the outcome, and those particular variables are studied, and and then we build a model according to that particular variables only. We don't build a model using all the 20 variables. So if we do that, right, if we do that, last session I was talking about the overfitting and the underfitting problem. So if we do that, so we will have the problem of overfitting or underfitting. So this should not arise when we try to build a model. So, for this, that is the reason we do the EDA process, right? So this EDA process actually will help us, right? So this EDA process will, identifying or doing all the process, right? So it will help us to identify which particular, which particular variable is actually contributing directly to our outcome. So that particular variables we use and we build a model, and which is used for the prediction. So once the model is built, we can pass the unseen data and we can try to predict whether, uh, you know, so that is where we study or we, use the visualizations to understand whether that particular data is not overfitting or underfitting, but it is fitting correctly without any problems. So this is where we do the statistical machine learning and deep learning algorithms. So the approach is different. If we apply statistical methods, it is different. If we do the machine learning models, it's different. And if you do the deep learning models, it's different. Maybe deep learning models are, bit advanced, right? So they are a bit advanced, and that is the reason, more in AI we are using the deep learning models. So it is they are a little more efficient compared to the traditional statistical and machine learning algorithms. So that is why for many models, we are using the deep learning techniques nowadays. Now let us go into the calling the data set. Okay, so this is the function to read the data set. So a small function which is pd dot read underscore csv. So here pd indicates pandas. Okay, so pandas is used to read the data, and we give the address of the data set. Okay, so this is my address of my laptop. Okay, so you can give the address of your data set and the data set and the I can say right, the address of your thing, so that you can read the data. So usually when you take the address, what happens is instead of this left slash, you will get a right slash in Windows. Okay, but once you read the data set, okay, sorry, yeah, so you will get this left slash like this when you take from Windows. Okay, so you have to remove this left slash and put the right slash, because Python will not read the left slash, it will only read the right slash. So this modification should be done. Okay, now here once I read the data set by calling the data set, the same data set what I have shown you, it will come here. Okay, so the same data set will come here. Now coming down here, so my data set has 333 rows and 21 columns. So there are totally of 21 columns. So in that 21 columns, my 21st column, which is the target variable. and 20 independent variables are there, okay, in the data set. So I've taken a small data set to, build a model. So here 333 rows are there, okay. So for banking data set, we'll go with a huge data set and and we will, use the credit card fraud detection. Okay, so now here coming to the data set, we have the age, gender, and sex or something. So we have the data set. Now already we have discussed on this. Now going down, I am actually renaming the columns. Okay, so there is a small syntax, which is can be used. This is an easy way to rename the columns inside Python. So in the original data set, the renaming will not happen. So if you want to rename in the original data set and import into the Python, you can do that. Then you don't need this data.columns function. But if you are actually doing just so that you can see. So now you can see all the columns. So here, if you use the function data.columns, the renaming will be done at Python level only. It will not rename at the Excel file level. So if you want these names permanently in your Excel file, you can directly rename them at the Excel level. So once it is renamed at the Excel level, obviously when you import the data with the same name, you will get. So that is not a issue. So or you can, if you don't want to do in the Excel level, you need not do that. So directly at Python level only you can do this. For example, here for age and sex, I have not changed, but for even for it is given as smoke, right? So I'm giving it as smoker. Okay, that means whether that person is a smoker or not. So next is the column is the years. So I've changed it to years of smoking, so that I will understand that, okay, this many years of smoking. So the same thing, you can do this cleaning part or renaming part at the Excel level also. That is up to you completely, how you want according to your data set. So the same thing everywhere, whatever I wanted, I think, see for FH, I put as family history, hist. Or you don't want hist also, you can put family history, full. Okay. So lifestyle, city or something like that, whatever you want or whatever name you want, you can actually give. So that is purely up to what you want actually. Okay. So once the this one is read, and then we read the data set, and then we'll go to renaming the columns. Okay. Okay. Now the next thing is the data.shape. So this data.shape is nothing but will give the shape of the, here we have taken the variable name as data. Okay. So that's why I've given this data and it has printed this output. Now, that's why I've taken here data.columns. Okay. Then we are going to the data.shape. So shape will give the number of rows and number of columns. So the first one will be the number of rows, which is 333, and the number of columns is 21. Okay. So this data.head function is optional. You want, you can give, or no need to give. Okay. So directly you can just print data, you will get the data. Okay, whatever data is there, so you will get. So head function will give you the first 5 observations in the data set, and tail function will give the last 5 observations in the data set. Okay, so you can use data.head and data.tail. Okay, head is the head part of the data, tail is the tail part of the data, or the back end of the data. So here you can see 0 observation because it is an array, 0, 1, 2, 3, 4. It will start giving numbers from 0. It will start 0 because we are using, arrays, no? So it will give the numbering from 0 to 4. So which is basically 5 rows. Okay. So next part, I think I didn't run this. Okay, sorry. This one, data.shape. Okay. So data.head. Right. So now coming to the next part, which is data.describe. So describe function is a very important function. So when you use the describe function, there are certain things which will be we'll be getting inside the describe function. So for describe function, this is basically what we actually have is the count, right? And we have the mean value, we have the standard deviation, we have the minimum value, we have the 25th percentile, the 50th percentile, and the 75th percentile. Then we get the maximum value. So these are the things which we'll be getting inside the describe function for all the values, which is the for the target. It is it is not it is calculating, but there is no use for calculating because it is ones and zeros, no? So what is the use of wherever you are having that zeros and ones, it is no use. So particularly for whatever is the categorical value, sorry, whatever is the numerical value. For example, the number of years of smoking, correct? No. So number of years of smoking, it is useful because you can see that the number is 4.79. That means 4.8 years. So average smoking years is 4.8. Correct. No. So maximum years is 50 years. So there is also a person who smokes 50. Okay. And the standard deviation is around 11.2. And the minimum is 0. So yeah, obviously the minimum will be 0 because there will be non-smokers also. So for cholesterol also, we can consider this value. For height also. So average height is 162 centimeters. Maximum height is 192 centimeters. Minimum height is 128 centimeters. So for numerical values, the data.describe function makes sense. Okay. For height, weight. For sex, it doesn't make sense, no? Because it is ones and zeros. It is calculating the mean value. What is the use? Nothing, no? There's no use. So it is completely based upon the the numerical values what are there. Okay, so that is how the function can be used. So now going down, the next data.tail I've already told you. It gives you the last 5 observations in the data set. So next we'll go with the EDA process. This is what I was mentioning about. So EDA is nothing but the exploratory data analysis. So EDA is a very important concept, which is, what EDA does is EDA does the statistical part or the analysis part in understanding the data. So for example, like missing values, extracting the features, what are the important features in the data set, whether the data is following the normal distribution or not. So all these particular factors will be analyzed in the EDA process. So the first part in our EDA process is basically the let's describe this one. So tail age. So next is the EDA. Yeah. So in this EDA process, the first one is the percentage of the missing values. So here I've given one function. So there is one small function. So data is the variable name, and a very small function which is in Python. It's very easy to implement as well. So the function is null dot sum. So that's it only. So if you give this is null dot sum, it will calculate, it will check whether there are null values in each column, and it will sum those null values. For example, age has some 5 null values. Okay, it will count. Okay, so 1, 2, 3, 4, 5. Okay, fine. There are 5 null values in age. So it will give the count as 5. Okay, so it will give you it will sum all the null values which are present in the data set, and it will give you as an output. So if you want to know the percentage of the missing values, you can also know the percentage of the missing values, right? So by using the total percentage. So here we are using the missing underscore data, and we are summing it divided by the shape of the data. Okay. And that total will be divided into 100. So once you run this, you will get an output where you have the total percentage. So in this data set, since I'm not focusing more on data cleaning and preparation, we are more focused on the methods to implement, right? So we are more focused on implementing this using a deep learning technology. So that is the reason I've not focused on data cleaning part. So here I've taken a data set where there are no null values. So we need not treat any null values, or we need not any what to say, we do not need any removal of null values or replacing the null values or something like that. So it is not required because the null values are actually not there in the data set. So now going to the other part, next is the after checking for null values. So the next part is building the histogram. Okay, so building of the histogram. So for histogram, why we build a histogram is there is a reason, right? So data.hist is the function. So data is the variable name, and hist is the function, right? So hist is nothing but for the histogram. So first of all, we should understand why we need a histogram. Why we need a histogram? So histogram actually checks the distribution of the data. So for example, you can see that the data is distributed in a nice way. All right, so almost the data is following a normal distribution. If not perfectly, but at least it is following. For example, if you see the, for example, like heart rate. Yes. So see the heart rate. So heart rate is where the data is actually distributed. So distributed well. So something which is following a normal distribution, which we call as a, then it is said to be distributed properly. Okay. So years of smoking, if you see, right, this is not normally distributed. The data is not normally distributed. There are many people who doesn't even smoke. Correct? No? Right. So now going down, if you see here the data on the Q wave, right? So Q wave, the data is not properly distributed. Even with the ECG is fine. This is also fine, but for Q wave it is totally extreme. Right? 0 is more than 300, and 1 is very, very, very less. Right? So what happens if the data distribution is not in a proper way is for the model to study the data and understand the patterns in the data, or how to understand the data, build a model. It will be very difficult for the model to understand this. So that is in where the the data distribution is extremely important when it comes to model building. So next comes the after understanding the or after building the particular histogram, where you can see some of the some of the variables are distributed properly, some are not distributed properly. Correct now? Yeah. So next comes the only heart. Okay. So let me take a questions. Any then we'll go with this part. Let me take some questions. So if you have any question, you can ask me till now, till what we have discussed. Please ask if you have any doubts. Just a couple of minutes, more. Sorry. I think nobody's having any doubt. I think we can continue. Okay, fine. Right. So now let us so since we have taken the entire data set and we are trying to find something which has this checking for normality, or you can say the distribution of the data set. Now, instead of that, let us understand, or let us take only the heart disease patients. For example, if we take only the heart disease patients, we have to take or we have to take the from the target. It is easy to filter out from the target variable, because we know that in the target variable somebody is having one, he is having a heart disease, and somebody who is having zero is not having heart disease. So our first we are creating a data set copy, right? And we are taking that in the target variable, whoever is having a the target as one, which will be which we can understand that particular person is having a heart disease. Okay, so who is having one, we are filtering it out and we are creating a histogram. Okay, so for those particular people, we are creating a histogram. So now let us see the histograms. So these histograms are little better compared to what we have actually built, right? Correct, no? You can just see. So many of the age, for example, it is distributed well. Maybe cholesterol is also fine. There is little skewness even in the cholesterol part as well as the age part, because the graph should be filtered. Should be like this. Chandra ma'am will share. Ma'am, please share the attendance and feedback. Yeah. Thank you so much. So, to understand this abnormality, or you can say the normality distributed in the data set. So here you can see there is little skewness, because it is usually the bell-shaped curve should be at the middle. Okay, that is where normal distribution actually tells us. So, the shape should be in the bell-shaped curve, but still you can see there is a, the data is, shifted to the right or shifted to the left and somewhat. So this is what causes difficulty. This is what causes difficulty when we are actually model building. There is little, skewness involved. So basically what is skewness is? Skewness is nothing but the error in the data, right? So this skewness is basically creates, whether it is a positively skewed or a negatively skewed. So, either way, the skewness is actually very difficult, or, not good to deal with. So that is where we build, we try to bring the data by identifying the outliers. So now let us go a little further before we close out the session. So next thing is the count. Okay. So why we count this data points? Because when we are actually training the data, our aim is to, for example, in this data set only. For example, let us take some 300 observations are there. So ideally, what we want when we are training the data set, we don't want any imbalance in the data sets. So this count plot usually uses, sorry. These are basically used to check the imbalance in the data. So this is basically used to check the imbalance in the data. That means when you are actually building a model, for example, here, since we are using it for we are building for heart disease prediction. We ideally want that the the count should be same. For example, those who are having heart attack should be 150, and those who are having heart attack should be 150. So it should be balanced out. So we don't want any imbalance in the data set before we are building a model. So, sir, how do we get a balanced data set? No, usually we collect the data. So we will not ask, no, like that, taking that if you have heart attack, you don't have heart attack, and we collect like that. We don't do that, no, sir. Then how we can balance it out? That is where we have certain techniques called the like the SMART techniques. So SMART, okay. So you can do some research on this. We can also discuss this later. So this is basically a synthetic sampling technique. So this SMART technique is actually a synthetic modeling technique, which will try to balance the data set. Okay. So for example, here, if we have 100, for example, let us assume 100, this heart attack patients are there. So, and there is a 300 data. So what it will do is, it will create a duplicates of this 100, and another 100 will be created, and it will match with that 200. Or it will randomly take 100 data points in the those who don't have heart attack, and it will match with the 100 data points with the those who are having heart attack. So basically, SMART, you can do undersampling or oversampling, or you can duplicate it also. Okay, so that's what SMART is very helpful, and it is a good approach only. There's nothing to feel that we are either creating a duplicate samples or we are undersampling. So this is nothing like that. It is just creating a balance, which is very good actually for building a model. So without without balancing it out, I don't think the model building is actually such a good idea. So always it is always important to balance the data. So that is in where we use the count plot. So SNS is nothing but for the seaborn, and we use the count plot to count the number of observations in the data set. So it will give you the count of how the so 0 indicates the number of people who do not have heart attack, and 1 indicates that those who have heart attacks. So to balance this out, we use this technique of count plot. So now let us go a little further. So we will see this distribution plot, right? Okay. So, and then we will, close out the session, okay, for today. So in this session, or in this, what we have done here, we have created a bar chart. Okay, this is a bar chart where it will plot the target variable, which is 0 and 1. So that means 0 indicates the person is not having heart attack, and 1 indicates that the person is having a heart attack. So we are plotting the graph. This 20.6 is nothing but the figure size. So you can give any kind of size, and here you are plotting the bar graph. So kind of plot is the bar graph. And here this plt.title, plt is used for matplotlib. I told you already. So for data visualization, we need to use the Seaborn or Matplotlib library. So here title indicates the title, whatever we have put here. We have put heart disease frequency for age estimate. That only, whatever title we give, it will come. X label indicates the x-axis name. So x-axis name we have given age. No? So here you can see the age will be coming. So Y label indicates the y-axis name, which is the frequency. So you can see frequency here. And show indicates that showing of the graph. Okay, so we have to use the PLT function, which is used for matplotlib. So we are plotting a bar graph with a size 20,6, and with titles, labels, we are plotting the graph. Okay, so for the target variable, so you can see the graph for the target variable. Okay. So till here, I think we can stop. Then I think from tomorrow, we can continue with this correlation plot. Okay, so we can continue with this correlation. So if you have any doubts, you can ask me before we close out. You can fill the attendance form as well. So I'll take some questions. We have some 3 minutes, 4 minutes left. You can ask me anything till what we have discussed. So we'll continue this project in the tomorrow's session for an hour or so. And then we will go to the, one more project on the banking side. We will do the project on credit card fraud detection. So please ask me kindly if you have any doubts. Till whatever we have discussed, you can ask anything which is related, all these things. Chandana ma'am, I think you can take over. I think there are no doubts. Code I'll share, sir. I'll share the code. Yeah.
Okay, Shashank, I'll take that.
Yes, yes. Thank you.
Yeah, dear faculty members, I'm sharing the attendance link again. So if you missed out this, please mark it. And I have uploaded that day one, day two PPTs in the LMS. You can go through that. And today's I will upload by tomorrow afternoon. Okay. Other than any questions, you can ask me here, or else we'll wind up. Sorry, Aziz, you can't able to download that material because it is in a PDF format. You can watch in that portal. Okay, like that only you have to read. May I know the link? Which link is that? Attendance or? Ma'am, on day one, I attended the class but not submitted the feedback. Okay, that's okay, no problem. Like we required only 60% attendance for the certificate, right? If you missed one day attendance, also no problem. Okay. From today, don't miss out. Usman, just drop an email to edl@exolo.com. Okay, I'm sharing that email ID in the chat. So my team will help you. Okay. I hope no more questions. We'll wind up the session and then we'll talk. Thank you for joining. Bye bye.